We're going to look at what's called the curved surface area of a frustum of a cone. So this is what it is. So the curved surface area of a frustum is pi multiplied by R1 plus R2 multiplied by L. And you're probably wondering, what on earth is a frustum? A frustum is a term in maths that refers to a 3D object when you sort of cut it off from the apex of a tapered solid. So that's confusing in itself, but this is what a frustum of a cone looks like. You can imagine that the cone would have kept going up here, but we've sort of cut it off. So we get something like that. You can also have frustums of things like pyramids. In any case, we're looking at this case of the frustum of a cone. So let's put some labels on things. We're going to call this length the slant height, which we're going to call L. We're going to call this length R1, because you can sort of see we've got a smaller circle at the top. So let's call that R1. And on the bottom, we've got a larger circle, which we'll call R2. Okay, and you can sort of see that if we did continue it, we would get a cone shape like this. Okay, this is the tricky part. If we were to unwrap that frustum, we need to realize that it's actually going to form a trapezoid or a trapezium, right? So if we come over here to just sort of explain things a little bit, if we have our slant height along here, and then we open that up, we can generate our frustum like this. And see, we've got a frustum of a cone here. But what we need to think about is if this was laid out flat. So if we laid this out flat, then this slant height would actually become the perpendicular height of the trapezium. Okay, because you can see that the spacing at the top is larger than the spacing at the bottom. So when you sort of stretch it out, the slant height will get stood up to become the perpendicular height of the trapezium. So if we come back over here, we can say a few things about this trapezium now. We can say that this length at the top is 2 pi multiplied by R1, which is the circumference of that smaller circle, because that gets wrapped around the frustum, right? That would be the circumference of this part here, the smaller part. And then similarly, the circumference of the larger circle would be 2 pi multiplied by R2. And what we just spoke about as well is that this, what was the slant height of the frustum, now becomes the perpendicular height of this trapezoid. And so what we can do now is we can apply the trapezium formula. And I encourage you to go research the trapezium formula if you're not sure, but the area of the trapezium is given by a plus b on 2 multiplied by h, where a and b are the side lengths of the top and bottom of the trapezium. So in our case, we're going to get 2 pi r1 plus 2 pi r2 all over 2 multiplied by L. Okay, taking out 2 pi as a factor, 2 pi comes out the front with r1 plus r2 all over 2 multiplied by L. Cancel the 2's out, and you're left with pi multiplied by r1 plus r2 multiplied by L. So that is the curved surface area of a frustum, which we're going to need later on when we're trying to find the surface area of what's called solids of revolution. And we'll get to that when we get to it. But hopefully that helps, and good luck with all your studies, and I'll see you soon.